Hello everybody, in this video we are going to see how binary search work and we will implement binary search algorithm in Python. So this is very exciting videos, so don't miss this video. Please watch the whole video so that you get whole concept. So let's get started. In the last video we have seen linear search algorithm. So linear search works by traversing the whole list one by one each element and compare them with the target value. So if for example if we have to find the last 12 value inside the list, so we have to traverse each and every cell and compare with the value with our target value. So this is a huge performance issue with linear search, because if we want to find the last value, then this will get whole resources of the PC and it does not work well. So because of this drawback, we have another algorithm which is binary search, which works better than linear search. So how binary search works? We have a list 1 to 12. Basically these are the values in the list and the index starts with 0 to 8. So there are 8 elements in the list and the start index which is 0 and the end index is 8. So we have find mid value from this formula. So here is my calculator. So let's find our mid value. So end is 8. So we have end value with having 8 index, then minus start index and divided by 2. So this gives 4, and then 4 plus start index will give us again 4. So 4 is the mid value. Okay, fourth index is the mid value, not the value. So at the mid fourth index we have 8 and the target is 10. We want to find 10 in this element. So now we will compare mid value, we will compare the value at mid location, mid cell with our target value. So as you can see that mid value is 8 and our target value is 10, which is, now you can see that mid is less than target. So as mid is less than target, it means that, sorry about that, I forgot to tell you about this binary search requires sorted array. Sorted list means in ascending or in descending order. So this is very important. This is the requirement of binary search. So as you can see that mid value is less than target value, so it means that our target is at the right side of the list, right side of the mid value. So left side and the mid value is useless for us because mid value is not our target value. Okay, and also the values less than the mid value are useless. So we will skip whole list at the left side of the list and we will just index with the mid plus 1. Means we will, mid is 4 and 4 plus 1 will be 5. So our start, we have updated our start variable with the index of mid plus 1. So because we want to skip this part of the list, because our answer is not here, our target value is not in that area, our target value is on the right side of the mid. Okay, so now again we will find our mid value by this formula. So you can find the mid value by new start value and the end value. So let's find the mid. Our end value is 8 minus our start value is 5, and this is 3. Divide this by 2 and we get 1.5. So again we will basically use in programming we will use double division operator, which will truncate or trim this with only 1, which eliminate the decimal point values. So this leads to only 1. Okay, so 1 plus start value, so start value is 5, then this will be added to 1 and this becomes 6. Now our mid value becomes 6 index. So at 6 index we will compare this with our target value. You can see that at 6 index the value at 6 index and the target value is exactly same. So this is, we have found the target value. In 2 iterations we have found the value. Now if we do this in linear, we want to this element, so we have to traverse 1 2 3 4 5 6 times, and the seventh iteration of the loop we will find we get our target value. So this is huge, this is very expensive algorithm, linear search. So at binary search you can see that at the second loop iteration we get our target value. So let's do another example, similar one. So this is another example. Now our target value is 7. Okay, so we want to find 7 in that list. So what we will do, we will set our start with 0 and end with 8, and we find our mid value using this formula. So this formula basically works that ends minus start divided by 2 will be evaluated first and then it will be added to the start. Okay, so you can find it by using calculator, you will get 4. Okay, so mid value is our 4th index and our target is 7. So at mid index we have 8 and the target is 7, so mid is greater than 7. So in this case, as the mid value is greater than our target value, it means that our answer will be lies on the left side, because our mid value is greater than our target value, means target value is less than the mid value. So as this list is in ascending order, so our target value lies on the left and the part to the left of it will be terminated, because this is useless for us, because we have found that we predicted that our target value is on the left list. So the list whole list will be basically whole list, our list is now in where becomes very small. So again from the next iteration we will first we update our end value with the mid minus 1. So mid is our 4th index, so 4 minus 1 will be 3. So we have updated our end variable. So then we calculate again our mid value. So our mid value is 1. So at 1 index we have 4 and our target value is 7. So again we compare this with these two variables. So you can see that mid is less than our target variable, so target value. So when mid is less than target value, then it means that the mid value and the values on the left side of this is evaluated, this is terminated, so these are useless. then we have to set our start value with second index. So how do we get this second index? The mid value plus 1. So mid, our mid is 1, so start equal to mid plus 1 will be second. So second index is start. Now again we find our mid value using the formula. So when we find our mid value, we get this index. 3 is our mid value. So when we get 3 as a mid value, then we compare them with our target value and we get the answer, means we found our target value in the list. So this is the graphical prediction, graphical representation of binary search. Now let's see how we code this whole logic in the Python. So for the time, as we don't have much time to write the code, I have write it down for you. So this is binary search. It again similar with the linear search, gets a list as an argument and the target value. Then we have set the start variable with 0 and end variable with length of the nums -1. Okay, so both the variables gets their value. We start the loop and we said that while start less than equal to end, means whenever start value is less than end, our loops will be executed. So as you can see that start value is 0, end's value is length of the list, maybe it can be any number of list. So this value is less than, so this loop is start working. So first we find the mid value by using this formula, and then we print it out to see what is our mid value. So then we compare this. So at mid value, what is the value at mid index? Okay, this is how we get our mid value. Okay, name of the list and in the square bracket mid, only index. Okay, mid does not have value. So this formula calculate the index. I can comment it down so that you can't get confused. So this is our index, not the value. Value is, we get the value by using name of the list and in square brackets the index of the list. So at mid index, value at the mid index, if value at the mid index is equal to target value, then we will just return found. We have found the item. So else if mid index, if value at the mid index is less than the target value, then what happens? As the mid value is smaller than the target value, means target is greater. So the greater values is on the right of the list, so we eliminate the left side of the list. So, and how do we eliminate the left list? Okay, let's see on this screen. As you can see that we are going to compare if value at the mid less than the target value, if value at the mid is less than target value, then we will eliminate our whole list. As the mid is less than target value, the values at the left side of the list will be eliminated. So how do we eliminate our left side and the mid index? So we eliminate by setting the start variable, by setting the value of, or by updating the value of start variable. As you can see that we set the start variable value as mid +1. Okay, so you can see that mid +1, we set the variable of start as mid +1. So in that, this results in elimination of the left hand side of the list. So If our value at the mid index is greater than the target value, then what happen? Let's see at the example. If mid is greater than the target value, then we eliminate our right side of the list from the mid value. Okay, so how do we eliminate our right side of the list? By updating the end variable to the mid -1, means we are going to one step backward. So our end value will be end equal to mid -1. So here you can see. So if this whole loop is executed successfully, we will return. If we don't find an element until if we get out of this whole loop, then we just return not found, because we don't find our value. So this is our main program, where we have test this binary search algorithm by providing the list and the target value, and our target value is 6. So let's run this. So here you can see that we have find at mid 2. So mid value is 2, 0, 1, 2. So you can see that at second index we have found the value, target value. So if we add something else which is not in the list, so you can see that we don't found any value. So this is for today. If you like my video, please subscribe it my channel. So thanks for watching. Goodbye.